Hello guys, welcome to Science World podcast. Virendra Kumar and you are listening about the classical magnetism. So, long before the beginning of the Christian era, it was established that pieces of the iron or magnetite found in magnesia have the property of attracting certain other substances, and if it was suspended freely, they used to point in north-south direction. These pieces are called the natural magnets, and the phenomena of attracting other substances is known as magnetism. So, you will listen to today in this episode about the magnetism and its properties. So, basically, magnet has some property. First is attractive property and their poles. When a magnet is dipped into iron fillings, it is found that concentration of iron fillings around it. The places in a magnet where its attracting power is maximum are called poles, while the places of minimum attracting power is called the neutral region. So basically these magnet have two poles and one neutral region. Directive property and north-south poles of a magnet. When a magnet is suspended, its length becomes parallel to north-south direction. The pole at the end pointing north is called the north pole, while the other pointing south is called the south pole. Do you know that magnet has its own axis and there is a magnetic meridian? So the line joining the two pole pieces of a magnet is called the magnetic axis, and the vertical plane passing through the axis of a freely suspended magnet is called the magnetic meridian. It has some length that is known as magnetic length. The distance between two poles along the axis of a magnet is called its effective or magnetic length. As poles are not exactly at the ends, the effective length is lesser than the actual length of the magnet. Poles exist in pairs always. The magnet has two poles always. You can't separate it anyway. In a magnet, the two poles are found to be equal in strength and opposite in nature. If a magnet is broken into number of pieces, each piece becomes a magnet itself with two equal and opposite poles. This in turn implies that monopoles doesn't exist classically. I mention it classically. Though you know that monopole do not exist, and in a magnet there are two poles of equal strength and opposite nature, but there can be magnets with no poles. Yes. For example, a magnetized ring called the toroid or solenoid of infinite length has the properties of a magnet, but no poles they have. Also, there can be magnet with two similar poles. For example, due to faulty magnetization of a bar, temporarily identical poles at the two ends with an opposite poles of double strength at the center of a bar can develop. So, if you have to check the polarity of a magnet, which pole is north, which pole is south, then the repulsion is a sure test of polarity, as a pole of magnet attracts the opposite pole while repels similar pole. But a sure test of polarity is repulsion and not a attraction, as attraction can take place between the opposite poles or a pole and a piece of unmagnetized magnetic material due to induction effect also. So that's why there is a test of repulsion, which is a sure test of polarity. Friends, do you know that a magnet has its magnetic moment? So, what is a magnetic moment? A magnetic moment of a magnet is defined as a vector quantity having magnitude equal to the product of pole strength with effective length, and it has a direction along the axis of the magnet from south to north pole. That is, it has direction only in the south to north pole. In Sommerfeld version in SI unit, it has the dimension of AL square and it has the unit ampere meter square. So magnetic moment has unit ampere into meter square. So further, very important thing that if a magnet is cut into two equal parts either along its length or perpendicular to its length, the magnetic moment of each part becomes half of the original value. As magnetic moment is a vector quantity, in case of two magnets having magnetic moments m1 and m2 with angle theta between them, then the resultant magnetic moment will be given by capital M is equal to square root m1 square plus m2 square plus 2 m1 into m2 into cos of angle theta. There are two pole pieces separated by distance r in vacuum, then the force between them can be given by the inverse square law. For example, if m1 and m2 are the pole strength and r is the distance between them, then the force acting between the two is given by capital F is equal to mu naught divided by 4 pi into m1 into m2 divided by r square. That is, mu naught is the permeability of free space. Now I will tell you about the magnetic induction. A magnet attracts certain other substances through the phenomenon of magnetic induction, that is, by inducing opposite pole in a magnetic material on the side facing it. There are two types of material, magnetic and non-magnetic materials. The substances such as steel, iron, cobalt and nickel, etc., which are attracted by a magnet are called the magnetic, while the substances such as copper, aluminum, stainless steel, wood, glass, and plastic, etc., which are not attracted by the magnet are usually called the non-magnetic material. The magnet may be permanent and temporary. If a magnet retains its attracting power for a longer time, it is said to be permanent, otherwise, it will be temporary. Permanent magnets are made of steel, alcomarks, ticonol, while temporary of soft iron. A magnet can be damaged. Yes, there may be a demagnetization. A magnet gets demagnetized, that is, loses its power of attraction if it is heated, hammered, or AC current is passed through a wire wound over it. A very interesting fact I am going to tell you that does the length of an iron bar change when it is magnetized? So friends, yes, it changes. In magnetization, due to alignment of spins parallel to the field, the length of the bar in the direction of magnetization increases. This effect is called magnetostriction effect and is used for producing ultrasonic waves by magnetizing and demagnetizing an iron rod at high frequency by the current in a wire wound over it. So friend, these were the things which I wanted to tell you about, and the next episode I will be coming with a very interesting fact and concepts. So please stay tuned and subscribe the Science World podcast channel because we are always bringing you the very important physics concept and facts, ideas and formula. So if you have any doubt, queries, please provide in comment box.